Hello kids, my name is Zui Zhang. I'm here today to teach you about covalent bonding. You're probably sitting in class right now just wondering what in the world is covalent bonding. Covalent bonding is when two atoms share electrons. This is usually between two nonmetals. When it is a metal and a nonmetal, it is usually ionic bonding. Ionic bonding is when one atom steals electrons from the other. This is different from covalent bonding.
Our first example is carbon dioxide, which is CO2. If you're learning in class to draw a Lewis dot structure, you have to do need, available, and shared. For need, each atom needs 8 electrons. So this one has 2 and this one has 1. So you have to do 3 times 8, which equals 24. For available, you have to look at your periodic table and find out that carbon has 4, and then oxygen has 6, but since there's 2 of them, you have to multiply it by 2, and you get 16. Now, for shared, you just subtract 16 from 24, and you get 8. To figure out the number of bonds, you have to divide 8 by 2, and you get 4 bonds. Now, when you go to draw the Lewis dot structure, C goes in the middle, since there are 2 oxygen should go on the outside. Now, since there are 4 bonds, there are 2 bonds in between the C and the O on each side. Now, each of these represent 2 electrons, so that's 2, 4, 6, and 8. And since there's a 16 available, you have to add 2 more on the top and bottom of each one. So you get that's 8 more, and which is that 16 available electrons.
Another example is H2O. To find out the need, hydrogen only needs 2 valence electrons instead of 8. So you do 2 times 2 because there are 2 hydrogen atoms. And for oxygen, it needs 8 valence electrons. So in total, the compound needs 12 valence electrons. And for the availability, you do 2 times 1 because there are 2 hydrogen atoms, and it only needs 1, and it has 1 valence electrons. And for oxygen, it has 6 valence electrons. So if you add those together, you find out that the compound has 8 valence electrons. And to find out the share, you would have to subtract 12 minus 8, and then you'll get 4. And if you divide it by 2, you'll find out that it needs 2 bonds. So to do the Lewis dot structure, we can hydrogen only needs 2 bonds, and it will be stable. But oxygen will have 4 extra electrons, so it could be stable. And that's how you complete the Lewis dot structure.
Another example of a covalent compound is carbon tetrachloride, which is CCO4. You can tell because both of these elements are non-metals. For the need, each one needs 8 valence electrons according to its OTEC rule. And there's 5 total atoms, which means 40 total electrons. For available, carbon has 4 and chloride has 7. And there's 4 of them, which equals 32. 40 minus 32 is 8 electrons. Divided by 2 equals 4 bonds that they need. Since carbon is at the beginning, you put carbon in the middle and chloride around it. With 4 bonds, you can put 1 bond to each chloride. Here you can see carbon has 8 valence electrons, making it happy and stable. Then you can fill in these for another 32 electrons. By doing this, you are making the chlorides happy with 4 valence electrons for all of them.
Properties for covalent compounds include low boiling points and low melting points. They also have various colors. They're poor conductors of heat and electricity, and when they're solid, they are very brittle.
Okay, when we look at the covalent structures, you have to take a look at your VSEPR chart. There are 2 columns, which is bonding and lone. Bonding is the number of bonds on the center atom, and then lone is the number of lone electrons on the center atom. So if you take a look at our example earlier of H2O, there are 2 bonds to the center atom, and there are 2 lone electrons on the center atom also. So for the electronic shape, it would be a tetrahedral. For the molecular shape, it would be bent of V-shaped.